Hello, welcome back to my channel. Let us discuss about dual behavior of matter. You know radiations have dual behavior, that is wave and particle like properties. Radiation is a wave as well as a particle. In 1924, Broglie proposed that matter like radiation has dual behavior. Earlier I told radiations have dual behavior, that is wave and particle like properties. Radiation is a wave and it has particle character. In 1924, de Broglie proposed that matter like radiation has dual behavior. Dual means both wave like properties and particle like properties. Matter means it's a particle, but it has wave character. So like radiation, matter has dual behavior. Dual behavior means particle and wave like properties. Like photon means quantum of energy in form of light. Photon is a radiation. Like photon, electron should have momentum and wavelength. Derivation of de Broglie's equation, lambda is equal to h by mv, where lambda is equal to wavelength of matter, p momentum is equal to mv, m is equal to mass of the particle, v is equal to velocity. We know E is equal to mc², that is famous Einstein's mass energy conversion. E is equal to h nu from Planck's quantum theory. Equating these two equations, mc² is equal to h nu, you will be getting mc² is equal to sc by lambda. You know c is equal to nu lambda, so nu is equal to c by lambda, or mc is equal to h by lambda. Why? Because c square is reduced to c and c on the right hand side is cancelled, so mc is equal to h by lambda. mc is equal to h by lambda, or lambda is equal to h by mc if the particle moves with velocity c. If the particle moves with velocity v, then lambda is equal to h by mv, or you can say lambda is equal to h by p. Conformation of wave character of matter. Bending of light at an obstacle is known as diffraction. Bending of light at an obstacle is known as diffraction. Similarly, electron beam like wave or light undergoes diffraction. So electron beam has wave character. Electron microscope is based on wave-like behavior of electrons. Like ordinary microscope, it can magnify to 15 million times significance. It is applicable to microscopic particles, not for bigger particles. According to de Broglie, every object in motion has a wave character. The wavelength associated with bigger objects has very small value because mass is larger. As mass is bigger, the wavelength associated with bigger particles has very small value, or it has no significance for bigger objects or macroscopic objects. And the lambda associated with bigger objects cannot be detected, so it has no significance for macroscopic objects. However, wavelength associated with electron, proton, or can be detected experimentally. Let us do one problem. What will be the wavelength of an electron if it moves with 663 meter per second? You know lambda is equal to h by mv. H is 6.626 into 10 to the power minus 34 joule second. Mass of electron is 9.1 into 10 to the power minus 31 kg, and you know the velocity of electron is 663 meter per second or 663 meter per second, so you can calculate the wavelength lambda associated with the electron moving with 663 meter per second. Thank you.